Right. So, good morning, everyone. Uh, my name is Jasper Paul, and I'm the principal product manager from Manage Engine Site 24/7 from Zoho. Right. So, today I'll be talking about observability and the need for it from an in SDLC perspective. Right. So, how do you incorporate that into your software development lifecycle? Why do you need uh, observability? I'll just introduce myself and why is this particular need and how it's going to help you in the digital age. All right. So let's start. So here's the agenda for today, and I'll just go through the growth of internet and the digital evolution, digital experience, and the technology that runs behind it. And I will then pivot into more technical details of why we should shift lefts and the DevOps culture and the need for observability and my favorite topic in the end, AI ops. Why you need AI ops and how it's going to help you guys. All right. So let me just start by introducing the need for digital transformation. So you might have heard this word digital transformation and the need for it. This all began when there was this growth in the internet, right? So back in the days, we used to have these modems and we used to have uh, wired connections, right? So that's when it all started. And uh, fast forward to today, you can see that as of February 2022, there were almost 4.6 billion internet users. Over 2.4 billion people around the world have purchased online. That's happening every day, every second. Okay, so imagine the volume of data, the volume of applications that run the world today, right? So, but if you take a little bit back step, so innovation comes from survival. So, if you have read about history, how internet itself started, the U.S. military wanted to communicate, and they wanted to communicate uh, across regions. So that's how the initial internet started, right? So the technology innovation itself, if you take companies like Infosys or AWS or Apple or closer Zoho itself, these were the companies that were pushed to the corners and they innovated. So if you take Infosys for example, uh, they started Softtronics, okay, and then uh, Narayanaswamy joined Patni, and then after a while they started Infosys with 10,000 bucks given by his wife. Okay, that's how Infosys started. Very early, very small, but they had a very solid goal. Usually, if you take Apple, Apple's market share actually suffered a lot in during the after the peak time from in the 1990s, and in 1996, actually experts wrote them off. They're going to be doomed and they're going to be gone. But Jobs introduced iPod, right? So that was the first ever MP3 player with which could play 1,000 plus songs. And then, of course, iPhone came and the rest is history. So similarly, if you take Amazon, Amazon was first launched in 1995 as a website only that sold books, and AWS was the infra arm of Amazon.com. And if you take AWS Business, uh, was created first by untangling the mess it into itself by well documented APIs. So, but no, so the APIs were the force that in which uh, Amazon.com transformed itself into uh, AWS that we know today. So, even if you take Zoho, dot com bubble was made us think different. So customers were reduced from 150 to 3 in those days. And then uh, we bet very early on the cloud business. In fact, Zoho CRM, one of the products, was started before AWS was born in 2005, and it evolved. Now it's an operating system for business. So here, if you see, uh, longevity is the key here, right? So you persist on a problem, you take it forward, and you achieve the end result. It's all hard work and longevity. And if you if you see, software itself is a craft. It's an art form that requires diligent study, it requires innovation, and it requires constant refinement. So this is the vision of the technology companies like Zoho, that comes from Sridhar Vembu himself. Right? So this is our vision statement. If you see, so if you take the digital evolution, right? So gone are the days when our lives actually dependent on papers. You guys know, shuffling between offices or booking tickets. This is what we are today. Everyday life depends on the internet. So you would have traveled wide and far along. Uh, this is a screen grab of the recent travel I made in for a local trip, on a business trip. No, I didn't take papers. I just had the QR scanned, went into the security check, and then boarded the aircraft. So if you take, it was just paperless. I just had the phone, the smartphone. That's it, right? So that's how many of you guys, or many of us, do our work or do our everyday chores today. So if you want to buy online, just go to the app and order. It comes to our doorsteps. So from multi-billion-dollar businesses to everyday small owners, we depend on IT, right? So if you take, uh, I'm uh, I'm sure you guys would know the UPI from the Indian market, where everything is digitized now. And if you see here, the tender coconut vendor is using uh, the QR code to be scanned, and the payment to be made, right? This guy is an everyday small vendor, and to businesses like AWS or Azure or Microsoft, Zoho, or anything you take, it's all digitized now, right? So these are multi-billion-dollar businesses, and the tender coconut vendor is a small vendor making around $1,000 a day, right? So this comes to the aspect of digital experience. How you want your customers to experience what you write code, how you write code, right? So in a recent customer experience, actually the only 15% consumers were happy. That was an online survey conducted for shopping applications, and this is according to research. So only 15% of consumers were actually happy of their shopping experience. If you take uh, digital experience, the the joy of doing digital, the happiness actually matters wherever you are in the world. So this is something that that's a payment failure I recently underwent when I was purchasing something online. I had to wait for a payment confirmation, and then I just you know got away, because I didn't want to wait for so long. I know that the payment I made was right, but one of the servers in the banks were not responding, and then I had to come out. Right. So imagine this for happening to banks across the world, and what's the final user experience? The final digital experience of buying the product, it's gone right here. So businesses actually look not to just satisfy customers, but delight them. So what will happen actually if you delight them? So if you see, the users will say, I am awesome, right? So I want to feel that awesomeness in me. So what do? Immediately they uh, talk to their friends, to evangelize and show off their results. So appreciate the value for high-end advanced versions. So get accessories, add-ons, and flaunt them. So seek out communities so they may spread your word. So resist the competition. That's exciting, right? So when you like something, you probably would have seen other 10 plus products, but you would still stick to the one you bought because you feel comfortable in that. So let's say Nike, right? So Nike is something I love, and I always wear uh, the shoes which are very comfortable. Even though there are other brands, I just stick to it. That's how uh, things work. So same for digital. So if you have an app and if you are in love with it, why do you want to go for another app, right? So let me just pivot myself into how these things work and how you guys as developers, as DevOps, as IT folks, how we are transforming ourselves, how we are equipping ourselves, and the background of how these things work. So if you take the system, there's an infrastructure as a service where all the hardware stuff, the data center network storage and servers, virtualization is all defined, and but the other end, right? So the top end, so the OS middle layer, the runtime environment like Java, .NET, and Python, and so on. The data, the application, and the functions are left to us. And if you take PaaS systems, this platform as service, you have everything till the data layer that is handled by the provider, and then you write only your apps on top of it and the functions on top of it. And now we have the fast layer. So the fast system has function as a service. You only write the functions, you don't worry about where your data resides, how it works, what's the performance of it. You only write your business logic, right? So and then the rest is taken care. The other world, that is the no code low code world, everything is done for you. Okay, you just have to have the workflows ready, and the rest is taken care by the SaaS framework, right? So that's how I would put this as two layers, four different parts. Sorry. So from self-managed to provided as a service, right? So now let's come to closer to what we are dealing with. So there is the traditional servers, VMs, networks, and so on, versus the modern day cloud and the containers, the Kubernetes, the Dockers, the mesh, okay, and so on. So, so if you see here, there is cloud native, Kubernetes, open source, right? So all these three combined have now become really, really, really powerful. E- uh, every business today depends on just go to cloud, right? So that's the strategy. That's how digitization works today. Even the enterprises now moved on. uh, so if you take the Kubernetes itself, like, so Kubernetes is now flexing its open source muscle. It is open source and it's used by millions of people, millions of developers, millions of applications are running on Kubernetes. So Kubernetes aligned with the emerging cloud native principles, which actually emphasized on microservices that the SaaS brought in, and its continuous deployments and the containerization aspect of things. So this is where Kubernetes was formed early in Google, and it's now scaled massively. So containers are the default for enterprise application deployments. That's what we see in our business itself. The open source ecosystem is addressing the gaps and solving for complexity with characteristic ingenuity. Okay, this is not my statement, but this is a statement from a research firm called 451 Research. This is a very reputed firm. So this they are actually saying that enterprises are now moving forward with Kubernetes. So this makes Kubernetes itself a massive, massive opportunity to code on, to write applications on, right? But still, we know digital experience at the end of the day, you guys need to purchase something or order something or you know ensure that your digital experience for the end customer, the end user who's using your code or your app you have written is performing well or is used to its best potential, right? So if you take the Kubernetes itself, there are so many parts that belong to it: the services, daemon sets, the pods, uh, the nodes that are running, the deployments, the replica sets, all these, right? So these are all uh, components in the Kubernetes cluster that you might have been familiar with, or you might start to work with. If you are in a startup, or if you are in a going to an enterprise, it's all the same. It's going to be most predominantly it's going to be containers and Kubernetes, right? So coming to modern IT, containerization, microservices, CI/CD pipelines, and how you guys observe that observability, service mesh, and application networking, and then the APIs, right? So the application programming interface. If you see, there is not petabytes, and then we have hexabytes, zettabytes, and yottabytes, right? So these are 10 to the power of 18, 21, 26, 24, sorry. Uh, those are the number of bytes that we are storing or we are customers are using digitally every day, right? So if you are writing logs, logs are going to be stored somewhere, and those are going to consume memory. And if you're writing apps, uh, the databases, the Redis servers, the MySQL servers, everything is going to consume data, and it's very important how you consume this data. So this is how it will be finally. You don't know where things are going on. Okay, it's going to go into a custom app, it's going to suppliers, it's going to mobile devices, the social, the SaaS world. A lot of SaaS components are involved there. For example, you do a payment service, that's a SaaS component. And this webinar itself, right? So we are live streaming here. This is unimaginable, like not 10 years ago. Maybe someone would have started it, but the amount of scale in which these streaming apps have blossomed in after, especially after COVID, is just mind blowing. And the amount of data that this brings to the table, it's huge, right? So we can't comprehend the amount of data we have, and that's when again digital experience plays a vital role here, right? So what are the three important aspects of digital experience? So primarily availability, because of course your your services have to be up and running, right? So it has to be available all the time, 99%, 99.999 percent available all the time. And of course you will have outages, you'll have issues, but still the SLA should be there, right? And then performance. Uh, if your app is performing slow, then 80 to 90% of them are just going to be frustrated and then move away. So there's a term in the observability world called slow is the new down. If your app is slow, or if your uh, if your service is slow, then it's as equivalent as down, right? So people are going to switch off or switch to another application. And then another aspect that is very vital today in today's world is security, right? So these three form the core of digital experience. And now, how is DevOps persona playing a vital role here? So I would just say uh, you can split the DevOps into two categories. One is obviously the developers, the development work, and the operations. If you see, uh, developers are primarily consumers. They write code, but the code has to reside somewhere. Uh, the code has to reside in your app. The code has to reside. The app has to reside in a server or in a functionless service, uh, and uh, the code has to have robust APIs, shorter life cycles. So this includes the infrastructure, the testing, and the deployment. Whereas the operations side, there is some you will have to have the visibility and governance. So governance meaning what kind of servers are you using? What kind of applications are you using? What is the version of the application server that you're going to use? What is the version of the MySQL database you're going to use? Those are governed by policies, by enterprises or even startups. So how do you deliver services quickly, right? And the operational consistency across these clouds that I mentioned here. So these are some of the aspects of what brings to the table for DevOps. The DevOps guy is not only an understanding of a person who understands code, but he also should understand how the underlying infrastructure works and tie both together. That's when uh, DevOps as a persona works together. So if you are a DevOps engineer or if you're a developer, you might feel the difference between what you guys are actually doing, right? So their developers are uh, business logic implementers basically, and the DevOps guys are ensuring your code is proper running in production, and if there is an issue, you solve this in runtime in real time, right? Yeah. So for DevOps, I am sure you guys have must have used at least 5 to 10 different tools for the DevOps, uh, the everyday work that you do as DevOps, right? So in every stage, there's going to be some tool or the other, right? So you deploy, you use infrastructure as code tools, or you use deployment tools. For testing, you use testing framework or unit test framework tools. For build, again, there's a whole gamut of tools that you are going to use. For coding, of course, there is a lot of IDEs that are available, and you are going to use them. And for observability as well, right? So you monitor and operate. Those are the things that constitute the everyday life of a DevOps, right? So now, if you see observability as as a topic in general, observability is something that you observe or you monitor, and you ensure that your uh, have the metrics that you want to, and to make the performance better for your app, right? So you observe right from your infrastructure to your networks to your application stack, and for your end user experience you have a whole bunch of metrics. So all these combined together uh, are together is called observability, I would say. So if you say, uh, then there is this real time observability. You can't just test it in your machine or your dev setup, but how are you going to do this in real time? So what are the tool sets that you have in your repertoire that ensures this digital experience is covered, right? So that's when digital real-time observability comes into play, right? So if you take this example that I shared previously, uh, so there's this waiting for the payment confirmation phase where I probably there was a API response time in session ID that took a long time. And if you see the bank's payment service that had certain cases, so and then the government authority itself, these are all microservices that are available for the purchase transaction. And then if you see deep down, you will probably have a session ID, right? So which particular user was affected. And if you take a banking service, you probably would have a microservice or a trace ID for that. And you will also have a session ID, of course. And the same with the government authority. So how you ingest the data, what is the telemetry that you have. So this telemetry comes in different means, right? So probably you'll probably have a session log. The government the government authority would have actually sent back to you a response in the API, and you would have recorded that in the logs, right? So in the access log. That's something that we normally use as application developers. And when this problem is happening, how do you correlate? How do you correlate all these data uh, into the problem that you are having, and then how do you actually solve that problem in real time, right? So for the production setup. So that's when we come to this part as the three pillars of observability, which are metrics, traces, and logs. Okay, so I showed you here as a sample. So the response time and the CPU server metrics that the application had was probably a metric, right? And the trace ID in which probably the code was executed that was faulty was available in a trace, and the error that you received from the government authority was traced in the logs. Okay, so these are three different entities of data collection that you are encountering, right? So these are actually the three pillars of observability, and there is one fourth pillar now, which is security, right? So how many people are using your, how many people try to log in unauthorized? What is the amount of traffic that came in that was unauthorized? So who did someone try to reach your firewall and kind of hack it? So what was there a DOS attack? These are some of the terms that we use today for in the perspective of uh, DevOps itself, right? So there's this new term called as DevSecOps. Uh, the DevSecOps persona uh, talks about, or his expertise falls under the security domain of how your application is running. So the WAPs and the IMAPs and so on. So if you take this modern SDLC with the CI/CD pipeline process, there's this plan, code, build, test, release, deploy, operate, and observe. Right? This cycle goes on and on. And for each stage of once you the deployment, the continuous deployment is over, the continuous integration kicks in, and this is an infinite loop. Right? That's the modern DevOps pipeline. So here we why do you need to do this, right? So shift left, I am calling this shift left because there's the need for observability should start really early, right? It cannot start at the end. The reason is, if you are starting if you are finding the problem at the end of the day, then it's not going to really, it's going to actually affect your digital experience for the end user, of course, right? So you basically have to start very early in your pipeline stage. In fact, in the coding stage, you have to ensure that you have the observability or the metric that is needed for you to measure the performance, right? So, uh, what is shift left observability? This brings actually some clarity and visibility into how you operate things. So you actually shift left into uh, the coding phase, the build test, and then observe, then get the feedback, and then deploy, operate, monitor, and then this loop goes on, right? So that's when you test a little early before going to production. So you will probably have three stages: uh, the uh, the development stage, the testing phase, the pre, and the production, right? So that's when uh, we usually recommend our team members to start the performance of to measure your performance of something that you have written very early. So you measure it, and to ensure that this works correctly and its performance it's at its best, you unit test it correctly, unit test it with different use cases, with scalability use cases, and then you go into the next phase. So if you say uh, this trace that I've put as a screenshot here, there is a lot of uninstrumented block of code. This is real-time data that you can fetch from tools, uh, from observability tools. Uh, so if you say the trace here, there's a lot of uninstrumented block of code, and that is actually consuming a lot of time for that particular transaction. Right. So here, if you see, uh, the observability tools can actually go into the line of code that you are uh, that this particular transaction was affected by, and then you can even go drill down into the SQL statements, the exception that occurred, and the remote calls that it executed. Right. So the observability tools of today are very advanced. So you guys, just put the tool in place or just instrument them. The tools are now automatically instrument code, and then you just have to put some script in your startup scripts, and then it's going to run automatically. So that's how these tools work today, and you get every single line of code that is executed, and that is part of a trace. So this is very important. So now after your instrumentation, so let's say this is an uninstrumented code, and you instrument your code uh, in your development stage, you kind of know what is going wrong, which business KPI or which business function that you wrote is actually giving you a problem. And the tool will be able to measure what is the impact of this particular problem that happened. For example, you can actually, if let's say you're simply writing a code that can call an Ajax function, and that in the backend it receives a function call, and the function actually goes serves another request to a payment gateway. All right, and this your code is probably one of the faulty codes that you've written, and then the payment gateway fails. Okay, or your or let's say your cart, the cart failure happens. Okay, that's your business logic you have written, and since the cart's failures is there, you should actually know what is happening and why it is happening, and what is the impact of this, right? What is the business impact? So due to a cart failure, there's going to be business impact, and there's money involved. And if you see the payment gateway, your money is actually not put into your bank account, and then that's a serious problem, right? So a seemingly small code can actually create a lot of problems. So I remember back in the days when I was writing code, I actually had a uh, while loop running, and this while loop was infinite. This was missed in one of the exceptions that happened, and this code was running infinitely, and the app server crashed. Like this was one of the real use cases that I had encountered, and we couldn't rectify that. So then we had to stop it and then restart, and a lot of things happened in the background. Uh, so this was one use case. But if I instrumented that code during the phase that was I was testing itself, probably I would have known that, right? So, uh, so what is the business telemetry that you can get from these observability tools? For example, the number of signups can be measured. So it can be instrumented or it can be coded so that you get the telemetry of number of signups. So you can uh, do automation tasks. You can do the scheduler counts, the number of users using a particular feature. That's a there's a user metric. That's an application business metric, and there are a lot of other examples that I can say, right? So in deployment automation itself, the CI/CD pipeline should actually include the resources that are needed for observability, right? So, and you guys should codify your deployments with tools like Terraform or uh, tools like Pulumi is there, and a lot of infrastructure as coding tools are there. So if you can bring that observability and that coding practice into your deployment itself, then it's going to be really really easy for you guys. And then you have to consolidate logs into a single tool for troubleshooting. So obviously if you are deploying something in your app servers, it's not going to be a single app server. It's going to be multiple, it's going to be a cluster, it's going to be a grid. And for you to troubleshoot in real time, you have to know you have to put everything into a single pane of glass. So if there is the logs, the traces, and the metrics, and if you're going to use different tools, it's obviously going to take a lot more time to solve the problem, right? So it's better to have this one single tool that you are equipped with and you know very well, and then ingest every metric into that particular tool. That's going to help you a lot, right? So observability here brings end-to-end visibility, right? So you might want to know what is your application service performance or your application codes performance. Like I said, the trace that I showed you earlier will actually measure the time taken for a function to execute. It will also measure the time taken for a query to execute. It will measure the time taken for, let's say, a uh, MySQL statement to execute, right? So this gives you valuable information of what when a problem occurs, you will get the valuable information of when the problem occurred, where it occurred, and how it occurred. So you can directly go into the code and fix it, and it need not be code every time, right? So you can have probably you would have a capacity planning problem, right? So your app servers are finally reaching its capacity uh, of its memory or its CPU, and you actually have to add another server. So probably the operations guy would say, "Hey man, your capacity is full," or you have to say, "My capacity is full. I cannot. This code will not run with the number of app servers that are available as of today." Right. So for this to measure this and to come to a data-driven conclusion, you need observability, and this gives end-to-end visibility, right? So if you see monitoring as code, as a statement, as a platform, as a best practice, so digital transformation itself has augmented the need for observation, and observation needs observability. It demands observability, and observability in fact injects data driven metrics, right? So metrics needs continuous monitoring. You can't say you can't monitor, let's say for one day. It doesn't make sense. You have to it has to be real time. It has to be every minute, or even every second. So continuous monitoring is needed, and monitoring invites operations. The operation guys are the people who are uh, interested in knowing this data, and the DevOps personas and the IT operation personas are the guys who are really in need of these operations and this monitoring data. And operation merges with development. That's when the DevOps persona kicks in, right? So if you see, if you see where I'm coming to, and development is code, right? So obviously, if it's development, it's right. It's someone has to be writing some code somewhere, some person, and that person will be you, right? So if you take this full journey, digital transformation to writing code, and how this relates, this will give you a better picture of why you need an observability platform and why you need these things into your bring these things into your SDLC process. So I would say some of the recommendations include monitoring in code, capture the business KPIs, uh, use the feature flags, that is the milestone markers, define the benchmarks or alter the existing benchmark for testing or in testing, add synthetics in your stages so that there's a real-time feedback from the tool. Synthetic meaning uh, you after you develop the code in your application, you run this test for some time. You run an automation, or you run a uh, real-time test, and that will test every 5 minutes, every time the sequence of steps that you have given, right? And make use of AI technologies. So I'll come here why you need this AI technology. And then, so this is something that a feature flag can do for you. Whenever a feature flag is set, you see the screenshot. I'm not sure if you can see it, but uh, there's a feature flag from an Amazon branch, and uh, it was committed during this time. And after that, what is my performance of my application, right? So this is something that is very vital for you to measure the performance continuously. And when you guys insert these feature flags, is going to help you compare before and after a new feature is developed, right? So let me come to the final topic of how you guys can leverage AI ops and how AI ops could help. So AIOps basically is, you guys have a lot of huge amount of data. I'm talking about petabytes and yottabytes here. Uh, it's humanly impossible to analyze them, and you need the assistance of AI technologies that the observability platforms give. Right? So these platforms actually evaluate past performance. Uh, it enables communication in real time uh, with today's Gen AI's technologies. It enables even more natural communication, right? So it can manage the flurry of alerts. It actually consolidates alerts, and based on the seasonal values or seasonal benchmarks that AI technologies like anomaly detection can give you. It will manage the flurry of alerts that you are having configured, right? And of course, data correlation across tools. It's something that the AI technologies can help you. It can correlate the trace with the metric or the log and give you a pinpointed result, or you can recommend solutions where it will help you find the problem very early. So the root cause analysis of a problem that was given as an incident could be found faster with AI tools with better correlation. And to have all these data, you basically need to have it in one place, right? So AI cannot do it. It can't do magic. It's still logical. It's still data driven, and the for results to be correlated, you have to have it in one place, right? So the metrics, traces, and logs that I talked about have to reside in one place. Otherwise, it's going to be impossible for any AI system to actually correlate and give you results. So uh, the AI system actually can have exhaustive training to prevent the false alerts. For example, the anomaly detection framework from the product I work with, Site 24/7, has this benchmarks. So, for example, if there is a Black Friday sale and there's this, there's going to be a lot of sales happening, and your your response time is going to be high. So similarly, if you're doing in a weekend, uh, you can either be uh, a spike in the response time, or if it's a business app, it's going to be low because it's a weekend. No one is going to use your app, and this seasonal pattern is being learned by the AI engine, the anomaly detection engine, and then it won't alert you if your response is very high in those time periods, right? So it knows that it is actually this is how it should happen. That's the learnt behavior, and it will suppress the alerts uh, because it has learned it. Okay, so that's something that exhaustive training from the AI engine will help you guys. So AIOps use cases, it helps in decision making, dynamic thresholding because of seasonal alignment. It helps you in forecasting, correlative actions, corrective actions, and then of course conversational chatbots. So let me also touch upon generative AI. So this is a statement from Lenin. So there are decades when nothing happens, and there are weeks when decades happen. That's when this generative AI means to us, right? So OpenAI, ChatGPT, and so on has actually transformed the way we think, it transformed the way we do work, and it's going to transform the future. It's already transformed, and it's going to really transform the future uh, of how things work in the application and how the digital experience you're going to give to your end customers. So there are three aspects of AI: predictive, causal, and Gen AI. Right. So predictive learns from the past and gives predict it it, it predicts the future and what may happen. And causal AI actually creates a relationship from the past metric, the past data that you have. That's the relationship that you have, because let's say your app and your server are in different nodes, and you want to have a relationship, right? So because of the problem that happened in your SQL code, your CPU in your application service spiked. How do you correlate? Causal AI is the answer. Causal AI will give you that causal AI algorithms that will give you that result. And then, of course, there is the generative AI, which is humanizing the way you interact with the system, just natural language processing, and it has huge amount of data that it will process, and this prompt engineering and all those stuff are very latest technologies that we can work on, and we are working on in some of these technologies. In fact, all three we are working on to give you the best user experience and the digital experience possible for the platforms and the applications, right? So finally, incorporating observability into your development pipelines will proactively detect potential issues, enabling us to rectify them well before an impact they can impact production, ensuring the best digital experience that you can offer to your end customers. So that's it from me, and thank you. Thank you guys for listening to me. And yeah, so I'm open to questions. If we have any questions, let's take it now. Okay. Okay. So, what are the key challenges organizations commonly face when trying to achieve full stack observability? And how does Site 24/7 address these challenges? All right. That's a very good question. So, as I said, right, so the first thing is uh, the full stack observability. So if you see, I talked to you about the metric traces and logs. Typically, uh, in a recent survey from an analyst firm, it was found that organizations use at least 10 to 15 tools for observability itself. So one department will use one tool for metric, and the same uh, another tool would be used for another department. And those two uh, departments would have services that are linked to each other. So for metrics, traces, and logs, there are of course a lot of vendors in the market that have observability and metrics and all those stuff, but very few have all together. And Site 24/7 as a product addresses this very well by uh, having the capability to ingest metrics, traces, logs, and any kind of metric that you can throw upon. So it can include a business metric, it can include a user metric, or it can include an application performance metric. So we have around over 600 technologies that are supported today, and of course, all the layers in the IT stack are supported from right from the network monitoring space, the servers, the cloud, the applications, and the end users that might be affected. Right. So the synthetic monitoring. These are some of the um, capabilities that Site 24/7 have, and this addresses most challenges. So this is something that actually, can give you the full perspective of a full stack observability from the Site 24/7's platform itself. Okay, I have another question. In your opinion, what are the core components or metrics that one should monitor to ensure comprehensive full stack observability? Right. So, the core components I would say are the application servers that you are actually monitoring, the end servers, and the application themselves. You need to instrument your code. So if you instrument your code, of course you'll need software or tools like Site 24/7 to that will help you instrument automatically. You just have to install a small agent in your application server so that it automatically instruments. So that is something that's vital for full stack observability, and of course logs. Let's not forget logs. Logs is very important for our everyday troubleshooting. Those three, I would say, the metrics. Obviously, when you are onboarding into a tool like Site 24/7, it's going to give you those metrics by default. It will also give you the logs by default, and once you put the agent into your application servers, it's going to give you every information at the code level and at the infrastructure level, and this all ties up together to form this full stack observability, right? So that's what I would say. Okay, so one question from Santosh: how do you monitor serverless compute solutions like Azure functions, cloud functions, or Lambda functions? Yeah, that's a very good question, Santosh. And so we have solutions, though The monitoring space from the cloud itself give a lot of telemetry to us. For example, the AWS CloudWatch, the Azure Monitor, or the Google Cloud. Those give us metrics in real time, and we use that to uh, monitor the serverless compute functions. And so you would have metrics like the number of executions and the cold start time. Those are some of the metrics that you would get out of the box when you are using serverless functions. And tools like Site 24/7 help you achieve that. So you will have, and then from that metric, you take a call on why it is happening and why is your number of executions down, right? So that will probably impact how your code runs and how your application performs. So I hope I answered that. Okay. Okay. There's another question from Tamil Selvan. Do you monitor or analyze for anomaly or ransomware activities? Right. That's a good question, Tamil. And uh, as of today, Site 24/7's capabilities pertained to uh, the application side of things, right? So we have the anomaly detection engine that will obviously detect when something goes wrong, when there is an anomaly, and when there is a ransomware activity. Uh, there are ways that you can do as of today, but the the anomalies of the or the ransomware activities that are happening can be found out from the metric that you are already monitoring in real time. That's how I would put this. So for example, if your response or your throughput is very high, that's an anomaly, right? So and then you are going to get an influx of uh, access logs that you are going to get in your logs, and then that will obviously say that there's a uh, there's an activity that you don't want to have, right? And if you go into your the server, and if your application or your endpoint is has a you know is infected with the ransomware, we have the managed engine portfolio of products has capabilities to address that. So that will we have this capability from a managed engine perspective. So yes, it is doable. Okay. So another question: how does Site 24/7 differ from other observability tools or platforms in terms of its capability and its ease of implementation? All right. So that's a very good question. Um, so yeah. So Site 24/7 has a unique um, market, right? So it is one of the very first tools to address the full stack observability problem, and the silos were merged together, and the silos actually brought in uh, us a lot of data, and tools like uh, Site 24/7 became an observability platform when we were able to monitor, or we were able to ingest all types of metrics into the platform. Right? So very few tools does that still. Probably no five, probably 5 tools or 10 tools. Even 10 is a large number, I would say. Uh, and we have some of the capabilities in the end user monitoring space, such as the locations that we monitor from, which are unique to Site 24/7, and we have a reputation of having very less false alerts. Right? So we have a lot of uh, internal technology that are unique to the product, and we have refined it over years. So in fact, if you see, Site 24/7 is 15 years old, and we have grown with Zoho, and Zoho is now enterprise, and all of Zoho and most of Zoho is now using Site 24/7 as its external monitoring tool. So with that, we have fine tuned our ability to negate false alerts. That is something we are actually very good at. and those are primary differentiators. And we are investing heavily on a lot of markets, a lot of feature sets that are new to this segment. So we are also invested in a lot of R&D uh, that are uh, mandatory for observability platforms because of the huge volume that it brings in, right? So the uniqueness, I would say, this full stack observability is itself is one of the unique standpoint for us, and we are available in a lot of markets. For example, we have data centers in 7 regions as of today. So the India region, of course, the US region, the China, Australia. Recently, we introduced Canada. We are introducing that, and then um, also regions like some of the regions like you know mm, Mexico and other things are coming up, right? So those are some of the regions that are available, and not so many vendors are there in the market today in those particular regions because of the mandate that governments have made. We have introduced in those regions, and that's some of the uniqueness that you can use to leverage the product itself. All right, excellent. So I would assume that was the last question. So thank you guys. Thanks a lot. Thanks a lot, Kunal, for uh, helping this in this webinar, and you guys have a great day. All right. Thank you.